Hello everybody and welcome to one more exciting video from Saranga Tutorials. In this video we are going to see the requirement elicitation step for automatic emergency braking. I explained in the previous video in my channel the importance of requirement elicitation. The general requirement elicitation step prominence for all the ADAS features. Now in this video I am going to talk about in detail the requirement elicitation step for automatic emergency braking, which is a very important ADAS feature. Now, when it comes to automatic emergency braking, below is the practical engineering ready way to elicit, structure, and lock requirements for AEB. And once these requirements are locked, you can find the specifications with concrete examples. In drop-in requirement text, you can directly paste into Polarian, JAMA, or doors. I'm sure everybody knows, or if you don't know, you please understand that Polarian doors is a important tool in which once the requirements are elicited, they are noted down. Now, what is the purpose and who are the stakeholders? Now, the purpose is to prevent, mitigate frontal collisions with vehicles and vulnerable road users, acronymed VRU, within a declared operating envelope, while preserving driver authority and comfort. All right. Now, when it comes to stakeholders, who are the stakeholders? Product owner, system architect, perception lead, controls lead, human machine interface, user experience, functional safety, and SOTIF is the acronym for safety of the intended functionality, cybersecurity, validation, operational design domain, brake, electronic stability owner, diagnostics and service technicians, homologation ratings, the key suppliers like camera, radar, ECU. So these are all the stakeholders in this requirement elicitation. The first step is define the operational design domain for AEB. All right. So first you have to make the ODD. ODD is acronym for operational design domain, and I will be using this acronym henceforth. Now make the ODD explicit. Okay, it should be as detailed as possible, and every performance number will be scoped into it. Okay. Now first is you have to understand the road type, whether it is a urban road or a rural road or a motorway or paved only or a lane marking presence quality. All these things should be clearly noted down. Next, you have to understand the ODD for different speed ranges. Okay, for example, when you're talking about 5 kilometer, 130 kilometer per hour, there is a separate bifurcation for 5 to 60 kilometer per hour, which is a safe assumption when it comes to urban driving, 60 to 100 kilometer per hour when it comes to rural driving, and 100 to 130 when it comes to motorway or highway. All right, and next you have to understand the geometry or the curvature of the road. Curvature of the road should be x per meter, or grade should be plus or minus y percentage. Lane width should be 2.8 to 4 meters. So all these values must be clearly understood. All these values should be clearly taken into consideration. All right, and next, when it comes to environment, you have to take care of the day and night. How many lux in the morning? What is the what is the lux value in the morning? What is the lux value in the night? Whether it is clear or light rain or heavy rain or light snow, on what is the visibility level? What is the visibility distance? All right, so all these things should be considered. Next is traffic actors. So who are the traffic actors? Whether they are cars or vans or trucks, motorcycles, bicycles, pedestrians, animals, optional. And when it comes to vehicle state, electronic stability control healthy, service brakes healthy, tire friction is greater than mu per minute. And when it comes to gross vehicle weight range, whether it has a trailer or no trailer, all trailer must be considered. And coming to when it comes to regioning, market specific signage behavior, regulatory rating protocols targeted. So for India there may be a separate protocols, for America there may be a separate protocols. So these protocols must be clearly undertaken or outlined. Next, of course, is the out of the ODD behaviors. What may be the eccentricities? Is there any eccentric behavior? What does the system do when outside? For example, does it dearm or was it deactivate the system, or does it inform the driver? Okay, so the final deliverable of this step is the step of defining the ODD is requirements that quantize each dimension, the speed, the weather, the illumination, uh, the curvature, etc., etc. All right, so this all these values, they come under the purview of operational design domain, which is a very important parameter in defining the requirements for any feature. Now when it comes to functional concept and driver interaction, which falls under the purview of human machine interface and user concept, write behavior as state machines with triggers. All right, as state machine with triggers, inhibitions and override. For example, when it is in off state or standby state, or is it going to give forward collision warning, and after forward collision warning AAB partial, next AAB full and degraded fault. So when the state is off, or first of all it is in the off state, then it is in the activated state or armed state, then it gives forward collision warning. First warning comes into picture, and then partial AAB comes into picture, and next full AAB comes into picture and degraded fault. All right, so this is the chronological order of the states through which the entire system goes through. Now arming conditions, under what conditions will the AEB get activated or armed? Vehicle speed should be greater than 5 km per hour. Forward sensor is set healthy, whether it is a radar or a camera, this should be set in a healthy manner. And driver seat belt latched, because this is extremely important. Some OEMs go to the extent of saying in a legal manner that if driver is not wearing the seat belt, the efficacy of this ADAS features will drastically come down. All right, and also electronic stability is available. Now, what are the various inhibitions? Whether it is a reverse gear, whether it is the yaw rate is greater than threshold, high slow press trailer, ABS active. These are all the various inhibitions. Now, when it comes to escalation ladder, how does slowly but surely AEB warn in a more alarming and a more alarming manner? First, it gives a visual plus single chime at time to collision. Okay, after that, continuous tone plus brief prefill at time to collision, T2, and next autonomous brake at time to collision T3 if the driver is not responding. Okay, so first it gives a small chime, next it gives a continuous tone, and next autonomous brake. Now when it comes to overriding and priority, driver brake or steering input above threshold cancels AEB, ABS, ESC always has authority. Now when it comes to comfort limits, what are the comfort limits? Maximum deceleration, jerk caps, hold time at standstill, release logic. These must be taken into consideration. So final deliverable of this step. What is this step? Functional concept of and driver interaction. The final step is the functional step and also the HMI step with time to collision, kinematic thresholds, human factors timings, and exact telltale text. All right. Now let's go to the next step. Now when it goes to coming to the next step, the performance and the fusion performance, what must be detected, how well and how fast. So in this step, the engineer or the requirement engineer will detect or outline how fast and how well must the scenario be detected and pursued. Okay, this can also be called as scope by class and scenario, and this is also tied closely to ODD bins. Now, when it comes to classes, passenger cars, trucks, buses, motorcycles, bicycles, pedestrians, generic obstacles, and use with care. All right. Now, talking about the KPIs, what are the metrics? What are the metrics with which the perception is gauged? For example, probability of detection. If the probability of detection is greater than 98% for car to car moving, targets within 120 meter at 60 to 100 kilometer per hour. First, you have to understand that you have, in the first scenario 98% of probability of detection is there, and 95% for stationary vehicles at less than 60 km per hour. All right, and probability detection 95% for adult pedestrians crossing 5 to 8 km per hour within 40 meters at 60 km per hour. And next is false alarm rate. Example, 0.2 events per hour, less than 1 event per hour, vulnerable road user in nominal ODD. This is so this is a fault alarm rate. All right, and tracking accuracy. When it comes to tracking accuracy, longitudinal RMSE should be less than or equal to 0.5, and lateral RMSE should be less than or equal to 0.25 meters, and velocity, relative velocity RMSE should be 0.5 meter per second. All right, now coming to the latency, this is extremely important, and scientists and engineers are always working to decrease it to the maximum, to decrease as much as possible. The photon to target list age less than 120 milliseconds, 95 percentile end to end per stage budgets allocated. So depending upon the allocated, the latency is decided. And also when it comes to confidence semantics, what are the various calibrated scores, decision thresholds mapped to risk, and policy notes that must be explicit. All right, for example, stationary object gating with high speeds, and the object conditions that ungate, example, map context, multi-sensor confirmation, ego deceleration. And when it comes to occlusion tolerance and reacquisition behavior, and also VRU confusion classes, whether it is a pedestrian or a signpost, or on the mitigation and mitigation. So these are the various types of VRU confusion classes. So the final deliverable of this step is, with numerical probability of detection, false alarm rate, accuracy, latency, all these things will be outlined or decided or concluded in this step of perception and fusion performance. Okay, this perception and fusion performance is an extremely important step as far as the requirement elicitation is concerned. Now coming to planning and control. Okay, turn perception outputs into deterministic action with clear limits and transition. All right, so in this step you clearly convert the perception outputs which were the output in the previous step of in the previous step we saw the various kinds of parameters that were concluded into deterministic action with clear limits and transitions. So first is the kinematic trigger for forward collision warning at time to collision is equal to 2 seconds. So this is the time at which the trigger will be triggered. And next is AEB partial at TTC 1.6 second if driver brake less than 0.1 within 400 milliseconds of forward collision warning. And AEB full when predicted impact speed reduction target cannot be met with partial brake. Okay, so when it comes to actuation limits, max autonomous deceleration 0.8 to 0.8, 0.6 to 0.8 G. G means 9.8 meter per second square. All right, so this is the one of the max actuation limit, and also jerk less than 12 meter per second cube, and ramp times explicit. So next is brake pre-fill pressure and build rates defined, throttle cut request on semantics and ESC coordination. So brake fill pressure must be decided so that the system applies the appropriate pressure, appropriate pre-fill pressure to slam the brake in the right way. When it comes to edge behaviors to elicit, cut-in versus gradual closing. Now lead acceleration drop versus hard brake. Okay, now coming to the split mu surfaces or split friction surfaces, downhill with trailer, stop and go creep after a stop. Okay, these are also behaviors that need to be clearly outlined. It need to be elicited. That need to be called for. Now it also swerve detection, high yaw rate with strong steering, inhibit AEB to not fight driver, and also this is very important. Okay, AEB should never fight the driver. AEB is always a servant or a slave to the driver. It should never override the driver unless the collision is imminent. So final deliverable of this planning and control step is the time to control, time to collision, the deceleration, the jerk curves, arbitration with electronic stability control and adaptive cruise control, and precise timing. Okay. Now comes the regulatory part, regulatory aspect. The first is safety and SOTIF. The first is the safety path. When it comes to safety path, first you have to take care of the HARA, which is the acronym for Hazard Analysis and Risk Assessment. And output of the HARA is a safety goal, which is used to avoid unintended high torque brake and brake torque and perform timely braking with collision probable in operational design domain. And also ASIL allocation often between B to D. Sometimes it can go to percent of D because, well, no prizes for guessing, because failure of automatic emergency braking can lead to fatality. All right, and also technical safety requirements like diagnostics, plausibility, and safe states. When it comes to SOTIF path, safety of the intended functionality path, identify the unknown safe scenarios. Example, sun glare causing a VRU miss. Sometimes the road users can be out of your range because sun is glaring right into your eyes. And it can also take care, it can also, because of the high contrast billboard as false vehicle. All right. Now, when it comes to mitigations, confidence aware behavior, multi sensor confirmation, human factors, guardrails, dataset requirements. And next comes the driver over trust controls, clear limits messaging, DRM outside ODD. And when it comes to deliverable, AEB, SAF 0XX safety goals and mechanisms, and AEB SOTIF 0XX linked to the requirements. So the final deliverable is the safety goal and also the SOTIF path. All right. So these are all the various types of requirements that are elicited during the safety, during the requirement elicitation step. All right. Now let's come to one very important requirement that must be considered as a afterthought, but this is important. Next, you have to take care of the degradation, diagnostics, and service. So define what limited means and how car behaves. So detection confidence low, reduce authority, shift thresholds or DARM, and also show AEB limited sensor blocked. All right. Now coming to the sensor actuator faults, camera blockage and radar misalignment, brake pressure sensor fault, electronic stability control fault, and safe state plus DTC's logging. Now coming to the self-test, key on checks, periodic plausibility, alignment monitoring, service recalibration and procedures after windshield or bumper replacement. All right. Now, so the deliverable of this particular step is the service repair requirements. Okay, so here you are kind of extrapolating or estimating what faults in the hardware can creep up as the time goes on. All right, hope you understand. I mean, this is more like you are estimating or rather guesstimating. A guess plus estimate is guesstimating. All right, now let's see one other important step, which is interfaces and timing. Now, freeze the interface control document, which is acronym the ISD, and timing budget. Signals, target list, pose, relative velocity, class, covariance, confidence, AEB request, brake torque request, and pre-fill request, forward collision warning level, health level status, timestamps, time sync. These are all coming under the interfaces and timing. Okay, so these are all the various signals that need to be considered. Okay, next, when it comes to rates and jitter, when it comes to rates and jitter, 50 Hz perception messages, max jitter of 5 milliseconds, actuation deadline should be less than 40 milliseconds. Okay, and as I said in the previous slide, the latency should be as low as possible. Now, when it comes to time sync, PTP or global monotonic time with DTP drift bounds, and when it comes to network, CAN Ethernet IDs, bandwidth priority loss handling, and when it comes to deliverable, this deliverable comprises of the interface control document and also the time values for various kind of synchronizations. Also, data and ML requirements. If vision ML is used, if at all the vision machine learning is used, what should be the data require? What are the corresponding requirements? The first requirement is treat data sets and annotation policies as requirements. Coverage quotas, percentage of hours per ODD bin. All right, ODD bin which comprise of the night, the rain, slow, regional, and VRU clothing contrast bins, occlusion percentiles. All these things should be taken into consideration. Now, when it comes to taxonomy and labeling policy, class definitions, bounding, instance masks, velocity labels, occlusion flags. These are the various taxonomy and labeling policies that must be encompassed. And when it comes to quality gates encompass the label QA sampling rate, the inter annotator agreement. Okay, for example, you have outer minimum limit called K, and sensor calibration drift bounds. Now, in case these particular values are going over your head or understandable or tough to understand, as on now, I recommend you just note down. Okay, you just note it down, and you can search on this because explaining these things is beyond the scope of this particular video. All right, so data and ML requirements. Within them, you have to take care of the offline metrics. You have to take care of the versioning and reproducibility. So the final deliverable is the AEB machine learning requirements and acceptance tests. All right. So to proceed further, next comes the most important aspect, which is cybersecurity and privacy. So even while developing the AEB, you have to ensure nowhere is it vulnerable to a cyber attack. So you have to take care of the integrity of the command path, authenticate AEB request messages, secure boot for ECUs, and debug ports locked. That is, this way you are totally blocking the attack path. Next is availability. Okay, DOS resilience on communication, rate limiting watchdogs, and when it comes to logging, temper evident incident logs with prior filters and retention policy. Now, taking care of the verification and validation plan, try to requirements, define how you will prove each requirement. Now, when it comes to scenario catalog, all the CCRS, CCRM, CCRB, I already explained what these acronyms stand for in the previous slides, and VRU, near side, far side crossing. All right. So all these various scenarios must be hypothetically imagined and tested, and only then after the testing is proved and approved, then you can say the verification validation is correct. And how do you do it? But with the help of software in loop testing, with the help of hardware in loop testing, also on the proving ground protocol maneuvers, on-road operational design domain sampling. And within the verification and validation plan, coverage metric like ODD coverage, percentage scenario, combinatorics, statistical confidence are clearly mentioned. So coming to the acceptance gates, what are the various accepting gates? When it comes to accepting gates, pass fail numbers for each scenario group, comfort bounds, whether the max jerk exceeds less than dash Newton per 100 kilometer, or frequency actuation rate over the fleet hours. All these things have to be taken care of. Okay, the last step, acceptance gates, is extremely important. This identifying the pass fail numbers is extremely important. So finally, the deliverable is the traceability matrix, whether the requirement can be tested, and if it is tested, is it passing the test, and the evidence that it has passed the test. All right, now let's give one use case or a standard example so that you can just modify the number. Suppose you have to develop a requirement elicitation on your own. Go just step by step, and depending on your vehicle, you can just modify the vehicle. I'm giving you a template. I'm just handing over a template so that you can just copy paste for requirement elicitation. All you have to do is modify the numbers. All right. First is identifying the operational speed range. The AEB feature shall be available and armed when the ego speed is between 5 to 130 km per hour, and the ODD conditions is AEB ODD 0.01 to satisfied. Now what is this? This is the first step which I mentioned in the previous slide. And this can be traced to the verification, field state machine test, HAL arming logic, and 20-hour on-road checks. Next step is the vehicle target detection. Vehicle target detection, whether the vehicle in front is moving at a velocity of 60 to 100 km per hour. The requirement is for moving lead vehicles within 120 meter, the system shall achieve probability detection of greater than 98% and a frequency activation rate of less than 0.2 hours events per hour, and longitudinal position RMSE less than 0.5 meter and relative velocity RMSE less than 0.5 0.5 meter per second. End-to-end detection latency. All right, again, to trace the verification, SIL, 5K SIL scenarios, CCRM proving ground runs on road 30-hour data set with 95% CI. Next is the stationary vehicle detection. In the previous step, we saw moving target vehicle detection, and stationary vehicle detection, you should be less than 60 km per hour. So the requirement is for stationary vehicles within 60 meters and ego speed of less than 60 km per hour, probability detection of 95% at a FAR less than 0.2 events per hour. Okay, so this is the requirement. And above 60 km per hour, stationary object braking shall require multi-sensor confirmation for AEB, and the verification CCRs, track tests, occlusion variants, rain dusk bins. So these are all the these are all the verification that must be traced from the requirements. All right. Now, when it comes to AE, next is pedestrian crossing detection. All right. Now, in the previous steps, we talked about the vehicle detection. Now we talk about the pedestrian detection. Now, what is the context? Urban UDD, ODD, 10 to 60 km per hour, and day night is greater than 2 lux or street lit night. And next is requirement: detect lateral adult pedestrians 5 to 8 km per hour, greater than 40 meter, with a probability detection of greater than 95%, FAR less than or equal to 1 event hour, and lateral RMSE less than or equal to 0.25 meters, and latency is less than 120 milliseconds. Again, this is verified with the help of VRU dummy test. Okay, I'm sure everybody has seen some videos where a dummy is crossing on the road and a car is driven perpendicular to the dummy to make sure or to ensure the vehicle stops before the dummy is collided by the vehicle. And next comes the forward collision warning and AEB activation thresholds. So issuing forward collision warning at TTC 2.0 plus or minus 0.2 seconds, and autonomous brake time to collision less than 1.6 seconds, and driver brake is less than 0.1 G or 0.1 into 9.8 meter per second square within 400 milliseconds of forward collision warning. Okay, so first comes the forward collision warning, and next comes the automatic emergency braking. Now, when it comes to partial brake shall ramp to 0.3 to 0.4 gram with 0.4 G within 300 milliseconds, and full brake up to 0.8 G with jerk less than 12 meter per second cube. Verification. And how is this verified? How is it traced to verification? Hill timing, track with soft target sled and jerk movements. All right, so next comes the driver alerts and the overrides. So forward collision warning provides visual icon and single chime, but when it comes to AEB, it escalates, so to speak, it escalates into a red cluster and a continuous tone, and driver brake is greater than 0.3 G, and steering torque is greater than or equal to 2.0 Newton meter, and it cancels autonomous brake within 80 milliseconds. Now, when it comes to verification, how is it traced? In the V model, when it comes to verification, hill cluster bench, human in loop, steady track runs. Next comes degraded operation, low vision confidence. The first requirement is if the camera confidence is less, or if it is camera is clogged and camera confidence comes down drastically to zero point 0.4 for greater than 500 milliseconds, or radar misalignment diagnostic trouble code is present or detected, the system shall de-arm or deactivate the automatic emergency braking. All right. So automatic emergency braking limited, sensor blocked or locked DTC AEB123 with timestamp and operational design domain context. All right. Again, there is a verification. How do you verify this? By fault injection and service blockage tests. Now, talking about end-to-end latency budget. Now, this is extremely important. Now, photon to brake pressure. The moment photon means the moment the light ray hits the camera. Okay. The photon to brake pressure command latency should be less than 150 milliseconds. And ISP less than 20 milliseconds, and perception less than 50 milliseconds. Fusion should be less than 15 milliseconds. Planning should be less than 10 milliseconds. Actuation should be less than 40 milliseconds, and residual margin should be less than 15 milliseconds. Okay, so if you make a cumulative of all these things, that comes under 150 milliseconds. And within this 150 milliseconds, this many actions are happening. And this is verified with hardware in loop timestamp tracing or oscilloscope pressure rise. Okay. So finally, command path authenticity. The AEB actuation requests over CAN Ethernet shall be authenticated. Unauthorized or malformed frames shall be ignored or logged, and recovery within 100 milliseconds after disturbance. So how is it verified? With the help of penetration test, which is commonly called as pen test or fuzzing or rate limit test. So to ensure that the CAN and the Ethernet are working properly, that is also a part of the cyber security requirement, which I touched upon in the previous slides. Now talking about the acceptance criteria, car to car rear all. All right, the requirement, the system shall pass 95% of CCRs, CCRM, CCRB protocol runs across the speed bins with residual impact speed reduction of greater than 20 km per hour. So in case the full avoidance is not possible, minimum 20 km per hour of reduction must happen. Greater than 20 kilometers of reduction must happen. Only then the impact or the severity of the impact will drastically come down. And also zero unintended autonomous braking events over 50-hour nominal ODD driving. Okay. So across a 50-hour nominal driving, there must be zero unintended autonomous braking, or unnecessary autonomous braking must be zero. Okay, and this is verified on a track protocol or a proving ground or flight pilot logging analysis. This is the name of the verification step. All right, so hope all of you got a clear-cut idea about the various steps involved in the requirement elicitation of automatic emergency braking. I thoroughly encourage you, go through this video thoroughly in case you are planning to elicit the requirements for automatic emergency braking. You can use this video as a step-by-step guide. Okay, thanks for listening and good luck. Oh, one small thing I forgot. So this is the checklist before you lock in the AEB requirements. The checklist is ODD bins, the state machine, the vehicle VRU perception, the stationary object policy, TTC kinematics, and diesel jerk curves defined, ESC arbitration agreed, safety goals, the degraded behavior, the ICD signals and data sets, V&V scenario catalog, traceability matrix. These are all the checklists. And the tips from the field which I would like to put forth in front of you is write every numeric target within its applicable ODD right next to it. Numbers without context will be misused. So whenever you identify a numerical target, make sure you are writing it right beside your ODD. And for every anything machine learning driven, require confidence aware behavior. Okay, confidence aware behavior in the requirements is a must, not just in the design. And decide early on the stationary object braking policy at high speed. Now this single choice drives most nuisance brake issues, and treat DTCs and logs as a part of your safety case. Never ignore DTCs, because these are extremely important when it comes to ADAS. Okay, so with this I conclude the recommended elicitation for automatic emergency braking. For more knowledge videos about ADAS, well, you can like and subscribe to this channel. And I also am adding my website through which you can enroll yourself into the full-fledged fundamentals of ADAS course in the description. All right, in the description you can find the link to Saranga tutorials through which I am offering my full-fledged course fundamentals of ADAS. But one important request is don't forget to hit like and subscribe on the bell button. Thank you.